Hi guys. Okay, so my name's Hunter Pickering. I'm from Missouri, Middle America. All right. Basically, this channel is going to be mostly like science interwoven with metaphysics or theology and consciousness. So how those three kind of aspects interact and what you can take from that, how you can apply that to your everyday life. I'm hoping that when I'm done, everyone will be able to take their own kind of version of this or their own perspective on this and understand something about their life that they hadn't known before or that they hadn't looked at in that light. So I'm hoping that I will have another episode on creation before, or like I'll put it in sequence before this one. This is technically my first live broadcast. I've deleted a couple, but they weren't put together very well. So this one's going to be a little bit more streamlined, hopefully, and hopefully it stays up there. I think it will. We're going to talk about hypercubes today. So I think one of these slides down here at the bottom left will show what a hypercube is, or at least dimensionality, because it'll go from 2 to 4 to, I think it gets all the way up to 8. I know it goes to 8. I don't know exactly how the sequence goes, but basically, I like it that it stopped at 8 because there are a lot of theories out there that use 12 or 16 dimensions, but to me, I think that all we need is 8. 8 is sufficient to create reality, and why go any higher than that? It doesn't matter. If you can't touch it, if you can't feel it, if you can't experience it, it doesn't exist to me. That's my point of view. It might to you, but that's fine. I'm not worried about that. Just for me personally, I want to use 8 because 8 it's lower. Why use more? Why make it more complicated, right? So anyway, that's the electron orbitals. That's not hypercubes. I hope it's in there. If not, I can quickly put it in there. Let me look, actually. Yeah, it is. It's in here. Well, no. That was hypercube. It might not be, actually. Let me look. Sorry. No, where is it? Oh well, I will find it at the end of the stream and I will show it then. Alright? That's a hypercube right there, so it gets you some sort of view. That's 4. So that's 4, but I think that in order to create reality you have to have 8 because it's just 2 of them, right? I mean, that makes sense. In order for something to interact, there has to be 2. You can't interact with yourself, but it does in a sense, which is super complicated. At the beginning, creation, it interacts with itself, but after that, not so much. So we're going to jump right in. We're just going to talk about hypercubes really quickly, all right? So before we get into spatial dimensionality and the necessity of hypercubes, let's understand why we must think of space and time as interwoven, all right? So Einstein's theory of relativity was really the first physical description in which space-time was a cornerstone within a theory's conception. What he said was that 2 different points of view on the same event will have 2 separate and differing times. He called it time dilation because it seemed to him like time would dilate the closer to the speed of light that a perspective was. So if a perspective was moving quicker than another, the time around this perspective would dilate. It would become lengthier. It would seem, if you were a third person observer, you have to have a third person. It would seem that this person, or that the one that was moving faster, would have a slower time than the one that was over here not moving, right? So he called it dilation. that's a grossly simplified version of time dilation, and there's a lot of videos out there that'll give a very good and in-depth view. So if you're interested in that, go look at those. I'm not going to get it too in-depth into it right here, all right, because we're not too worried about it. I just want you to understand that time and space must be within the same framework if you're going to describe one or the other. So if you're going to describe space, you must have time within that framework, and vice versa. Just a little something to chew on would be, if consciousness, or people, if you didn't exist in the universe, would there be time? So another way to think of this is, if nothing were here to experience a progression of events, would there be such a thing as a progression of events or time? Would there be, like, and to me, like, the only reason I asked this is because I thought to myself one time, well, if we weren't here, the universe would just be. It wouldn't know any better. It would just be itself at any given moment. So it would never realize that it was something different. It would just be, right? And so, but you can create your own. So that's just something to chew on, something to think about if you're bored, which it's kind of a weird thing to think about, I know, but that's how my mind works. So just decided to throw that out there. So now that we understand that space and time are intimately connected, let's create a framework for this understanding. Light is probably my favorite subject. It's the most interesting thing to me. It's what got me into physics. It's what got me into spirituality. It's what got me into all this stuff. Really, I was in my bedroom. I remember it like it was yesterday, and I was thinking about, well, I don't want to die. How could I live forever? And I had heard that speed of light kind of acts like time doesn't exist. It's basically like there is no time. So I was like, well, how could I reach the speed of light? That's what I was looking for, and kind of got me interested in it. Now, I'm not quite on the same trajectory now, but it's just that's kind of what sparked it. So light is pure energy. It's the universal speed that you can't pass the speed of light. That's the Einstein law. And then as I'm going to show you, it is the ultimate timekeeper. It is also the time threshold. You cannot know any time outside of light. So, light also involves one of my most proud moments in my life. So I was trying to figure out what the shortest time increment could be, because I was developing a theory back in high school where everything was expanding at the speed of light. Everything. And that's where the hypercubes kind of come in. So I imagine that the small spatial dimension was expanding outwardly at the speed of light. And so I was trying to figure out exactly how a body, I basically used myself as a example. If I were moving, I was adding more energy to my energetic state. So I was already moving at the speed of light, right? My body at every point. And then I was also moving on top of that. So I was trying to decipher how that would actually work, because Einstein said if you moved past the speed of light that you would gain mass. Or if you got near the speed of light, I shouldn't say past, you can't move past it unless you're a tesseract. Wait, is it tesseract? That's Land of the Lost, but that's what are they? Tachyons. The tachyons are a real thing. Yeah, I know, it's Will Ferrell whenever you say it, right? But tachyons are a real thing. The physicists actually use them, but they're not. I don't think they're real, to me personally. Unless you're talking about spiritual realm. If you talk about the spiritual realm, moving backwards, yes, maybe. I don't dismay that. But anyway, so Einstein said that if you were moving close to the speed of light, so this is the speed of light and the pin is close to it, right? So if you start getting closer and closer to it, the universe will start adding more and more mass to you, because it doesn't want you to reach the speed of light. Basically, it's kind of the understanding that I get from what he describes. So it's basically the universe keeps adding mass to you, because the energy starts turning into mass, and you have to and in order for that mass, because it's becoming more massive, you have to have even more energy added to it in order to keep that speed up. So I was trying to decipher that along with my new theory of everything expanding, right? So it was really confusing. I was trying to, so I was dividing, I started dividing up the points in which I was moving into the smallest increments. And so I was trying to figure out what the smallest increment of time could be. And so I started deciphering this, or started thinking about this, and I was looking at a light wave. And I was thinking to myself, well, this is the fastest thing possible, right? And if it's the fastest thing possible, I could measure how long it takes for this thing to get from here to here, and that would be the time, right? So I could figure out, well, if I can divide how long it takes for the fastest thing possible to get to the smallest distance possible, then I could figure out the smallest time possible, right? And so I kind of deciphered that, or I kind of figured that out on my own. Back in those days, I didn't like to Google anything. I didn't Google anything. I was just, it's me. I'm gonna figure it out, right? So I was kind of prideful in that aspect. I Google stuff now if I'm kind of stuck. I think that it was really good for me back then because it kind of developed that drive and that knowledge, like figuring stuff out on my own. I didn't just rely on a source, right? And so luckily, in math class, we were studying sine waves. And so I knew that a sinusoidal wave, which was light is in a sinusoidal wave, that if you take the 2 points at its maximum, it is actually 2 pi. So I divided the speed of light by 2 pi, and I tried to figure out what that time would be. But I didn't understand nanometers, and I didn't understand how to increment time into a sine wave. Basically, like how would I cut that up using seconds, right? Or using like any time. So it still doesn't make a whole lot of sense to me because we're given these numbers. Okay, Max Planck had figured this out 1933, I think. So it was in the early 1900s. And I made my own number. I have my own number somewhere, but it wasn't quite right. It was weird. It wasn't a good number. And I knew it probably wasn't right, so I ended up giving up and looking it up. But it was more important to me that I actually knew how to get to this time than it was to get the right number. I understood the concepts more than I understood how to get the number. And that's kind of, as you'll see, that's kind of how I approach it's how I approach life. It's how I approach physics for the most part. Is I feel things out really well and I understand things really well, but I don't always necessarily know the methodology to get to a correct point, which is somewhat worrisome, but I understand the concepts and I love the concepts even more than I love the actual results. So I keep working at it, and I think eventually I come up with really good ideas, and I come up with really good things that are testable. So I would consider myself more of a theoretical guy. I'm not really a practical, like, this is what it is. I'm more of like a, let's do this, and someone else does it, right? That's what you guys are for. But that's one of my biggest moments. Not my biggest, but one of my biggest moments as far as these studies go. They get bigger every time, obviously, because if you keep working at it, you're building on top of what you've previously gotten, so it automatically is bigger, feels better. And this is kind of alongside the spiritual side of everything, because I think that God, or the creator, or knowledge, or love, or the aliens, if you want to believe that, it is giving us, it's like this big mountain, right? It's a big mountain of knowledge. This is everything that could ever be known. Okay? We're down here, and it sprinkles stuff. You have to come up. You have to come up and reach it, and it'll give it to you, right? And so whenever that happens, you are at this level. So the next time you think of something, if you think of something dumb, it's down here, and it doesn't feel very good, right? It's like, oh, that wasn't good. But then if you get closer to the peak up here, it feels real good. So that's my goal, is to get towards that peak. But just kind of a side note. So what does this have to do with hypercubes, right? Well, let me tell you. So, light is the most pure form of energy, and it is the fastest. It is the fastest speed possible, right? Coincidence? No. Okay. As you can see right there, it pops up perfectly, perfect timing. Okay, so it is the oscillation of a magnetic field and an electric field corresponding. And then this is an electron and a positron annihilation, which is also a perfect demonstration, because what happens is an electron is exactly negative. It's exactly negative charge. Positron exactly positive charge. They come together, they annihilate, they create a gamma ray. Okay, gamma ray shoots off in both directions. It's not just one direction, it's both, which is important later, as we'll see. So a hypercube. The hypercube is the electron and the positron. The positron and the electron, I think, are the two most fundamental forces. They're the two most, like, I know we have quarks. Quarks are inside of protons, which make them, I think, it deludes them a little bit, because you can't actually see them, you can't actually understand them. They're more of a concept. So an electron and a positron, we know they're there, right? For those of you who don't know, a positron is the anti-electron. It is the anti-particle of an electron, which at the beginning there was particles and antiparticles, and they ran into each other and they created all this energy. And that's what we are probably the aftermath of that energetic state. I know, crazy, right? You thought you were just a star. Nope. You're an anti-electron positron annihilation. Wait, no, that's the same thing. You're a electron anti-electron annihilation. All right. Anyway, you have these two forces that are in the. They are created through I won't consider my hypercube. I haven't seen anyone come up with this stuff yet, but there might be someone out there. Don't know. They've come up with some stuff that's really close and really cool. It's called, like, the Lie diagram or Ley diagram or something like that, and it's basically the 24 fundamental forces all interacting and becoming something. They can basically tell you how all of 24 come together and interact and become something else. That's basically what I'm talking about, okay? But mine's only 8. You don't need 24. It's kind of funny, right? 24 is actually the 3 8s. So they have 3 hypercubes coming together and creating one thing. I think you only need 2. You need an electron and an anti-electron, right? They come together, they create energy. What happens whenever so you have this super positive and this super negative hypercube. So you got this guy, and the box is all the way up at the top on one of them, and the box is all the way down at the bottom at the other, on the electromagnetic wave, on the electromagnetic spectrum. And I have another theory on what the hypercubes actually, because we have we have 4 fundamental forces that we know about. Gravity, the weak force, the strong force, and the electromagnetic force. But they've come to the conclusion that they think that there's a weak magnetic force and a weak this is brand new to me, so I can't really speak on this too well. There's some sort of interaction that they have between the electromagnetic force and the weak force. I'm pretty sure. So, to me, that just tells me that I'm onto something, that it's right, that I think all four of them are interwoven, and whenever you interweave all 4, you create a hypercube. And so you have them interacting in certain ways that creates a spatial dimension, right? And so whenever depending on how this spatial dimension is put together, you get a certain output. You get either positive, negative, or a semi-positive, semi-negative quark, that kind of thing. And then whenever they're semi-positive, semi-negative, they can come together to create a proton, they can come together to create a neutron, and all that stuff. Cool? Kind of with me? Basically, what I'm trying to say is that there's 8 spatial dimensions, and they create hypercubes. Whenever you get a hypercube interacting with another hypercube, you can get certain phenomena. And the one that I'm most concerned with is light, because it's pure energy. It's the energetic state. And what happens is you get this rip. I think it's a rip. Feynman actually created this kind of thought process, and I don't have very many references. I don't know how YouTube actually works. I haven't actually started with my YouTube stuff, so if I get sued, take my apartment, because that's all I have, really. Car, maybe. Okay, you can take my car. How about that? But whenever this happens, so Feynman created this theory that an electron, there's only one electron. That's what he kind of thought. He thought that there was only one electron, and that it was the same one at the beginning and the same one at the end. And that you can actually, he said this because you can actually look at the universe as though it's going forward in time, right? That's how we all think about it. It's pretty normal, natural. And then but you can also create a anti-universe going backwards in time. That is, it's just as correct. You can actually do just as good physics going backwards as you can going forwards. So there's a lot of cool stuff that comes out of that. It's not just that. That sounds pretty basic. You're like, well, duh, you could. But anyway, it's a lot more complicated than that. But the main thing that I want to talk about is that electron. It's a single electron, okay? My addition to his theory would be that this electron, it is the same electron, and in order to get from point to point, it drops through dimensions. It basically starts at a higher dimension, and then whenever it wants to get to a lower dimension, it drops through. And whenever it drops through, think of these little sheets, right, that are running underneath it, and it falls. It keeps falling through these little sheets, and as it falls, they break. And as they break, there is an electromagnetic force that comes out of it, which is light. Crazy, right? Pretty simple, but it's crazy. So here, I'll draw that for you. Boop. It actually comes down like that, rips, and then it comes back up. Boom. And then we got, so you got one here. We'll just make two of them real quick. And this can be seen, there's a lot of cool things that you can do with this. Like there's electron points. No, what are they called? Electron jumps. Frick. I can't remember what it's actually called, but basically you have an electron on a sheet, and there's a barrier between two sheets. Okay, you got two sheets. There's an electron on a sheet, there's another one over here. There's a barrier in between that the electron shouldn't be able to jump through. It's too energetic, so it's too positive, basically. So the electron can't get through it. But every like 1/1,000,000th time, that electron will, it's electron tunneling is what it's called. So you can look it up, electron tunneling. And so it jumps through the barrier that is supposed to be stopping it, right, from jumping to the other sheet. And the reason for this is because of this kind of stuff. So there's some sort of pull somewhere else in the universe that creates a chasm so deep that it rips this actual piece of space-time, and the electron's able to jump through really quickly, and you don't even notice, and it just jumps. Boop, boop, right? Pretty cool. Okay. Let me change my color, because electrons are always red, obviously. If you ask God, he says, yeah, electrons are red. Just kidding. Falls. And sorry about my drawing. Okay. And now this, so you can think of, this isn't like a literal like up and down fall, but that's kind of how I picture it, just because I'm human. But excuse me. It's not really a fall in a sense. It's more of a traverse. It goes through time. It's going through space-time, because space and time, like I said earlier in the beginning of the video, they're interwoven. It's not one or the other. It is both, right? And so what it does is it creates it's a rip in space-time. All right, and whenever it creates this rip in space-time, the universe has to make up for itself, because the universe hates being asymmetrical. And I'll say this a lot, it hates it. I don't know why. I mean, I do know why, because it's always trying to get back to this state of equilibrium. It's trying to become what it was in the beginning, for whatever reason. But what it does, whenever it creates this rip, whenever this rip is created, it's like, well, shit, now we have to put something there in order to get rid of this rip. This rip cannot stay. We cannot have this rip here forever, because then everything would fall apart. Right? So what it does is it creates these, I think that they're equally energetic states of light, right? Both sides. And this is seen in like the hydrogen atom and all that kind of stuff. And I'm gonna post a video on like Newton and why his theory of or his law of conservation. No, that was dumb. His law of cause and effect is so intricate into this kind of stuff. Basically, you have to take in consideration that the energy started has to be the same energy that ended, right? We'll get to it later. Basically, what I want to talk about, what I want to say about that is that whenever this happens, I think that there is a rip between hypercubes, and the hypercubes push light out at the speed of light. Crazy, right? I just hope someone sees this, so that way the theory is at least out there, because I haven't heard anything close to this in modern physics. There might be something in the back rooms of string theory or something similar to this, but nothing this raw, because they're going to use so much weird language, so many weird equations to try to prove all this stuff that it's not going to really make sense to you and me. I mean, I might be able to decipher some of it and I can figure stuff out if I read it long enough or I try hard enough, but as far as like nomenclature, it's not going to make any sense. So for me, this is more important, to tell everyone else there's something out there, and it's important, and it's not crazy, it's not scary, it's not weird. It's part of everyday life. It's really cool. It's fun to think about, and I think that it'll actually like help you in your everyday life, if that makes sense, because it'll basically bring to light things that you wouldn't necessarily like. This is intricately tied to your own thought processes, because your own thought processes are a form of energy, so that means that they're tied to this. And whenever you think about stuff, it will exacerbate some sense of connection to the universe. So that's really all that I had. I didn't really have a whole lot planned for this first video, but if you liked it, subscribe, comment, whatever you want, because I'm brand new to YouTube. Let me know what you think. I'm here for criticism. If you have any, just let me know. I know my background sucks. My chroma cam isn't working right now. I need to figure that out before the next video. But hope you all have a good day, and hopefully you learned something.